Alright, this recording will form part 1 of 2 videos. As you know, this activity actually has 2 parts, right? It has 2 parts. The first part is proving identities. The second part is all about simplifying trigonometric expressions, right? So I felt like recording one video for both activities, it was gonna take a bit longer, so I split it into 2. There's part 1 and part 2. The part 2 will be covering simplification of the expression, right? I'll also leave the link of that recording in the description box of this video. Okay. Just a side note, if you are a grade 11 learner and you are watching this, stay tuned. There's something that you're gonna learn, right? Because level 3 NCV and grade 11, they're somewhat at the same level or having the same content. Okay, so level 3, we are only dealing with 2 identities. This one being the quotient identity, this one being the squared identity. Okay, so this activity, the first part of the activity, proving identities, has sums starting from A all the way up to H. So we're gonna be answering all those questions. So the first one, we have a sine x adding cos x, everything divided by tan x plus a 1 equal to cos x. So we have to prove that the left hand side is actually equivalent to the right hand side. As you can see, that this side can be simplified. Here we only have one trigonometric ratio. Okay, so we also have an identity of what? Of tan x. So this needs to be written as that. Okay, has to be written as sine x over cos x. So there's more work to be done on the left hand side. So that's what we're gonna do. A, okay, cool. That's A. So for A, I'm gonna take the left hand side. The left hand side is equal to a sine x plus a cos x over, then I'm gonna change this tan x. I'm changing this tan x to a sine x over cos x plus 1, right? Plus 1. But this 1 should be divided by 1 so that I can have a fraction adding another fraction. Meanwhile, if I had left it like this, right, it's actually, let me not say not possible, but it's kind of I should be adding a fraction to a fraction, right? Similar to saying I'm adding a centimeter to a centimeter. Same units can be added. I'm adding rands to rands, right? You cannot add rands and cents, okay, and cents. So the units should be the same. The units should be the same. So similar to this, I have a fraction adding a number, a whole number. So what should happen is that we need to change this one into a fraction. So since 1 is not a fraction, in order to turn it into a fraction, we have to divide it by 1. So that's what's happening here. Me dividing the 1 by 1. So I'm trying to change it to a fraction. So u multiply by u, and then u multiply by u. I'm doing the butterfly method here. So simplifying this further, it's going to be a sine x plus cos x over, so 1 times sine x, that's sine x, plus cos times 1, that's cos x. And then for the final calculation on this butterfly method, it's multiplying the denominator as cos x multiplied by 1. It's going to be a cos x. Okay, remember, we have to show that the left hand side is equal to the right hand side. So we are now faced with a situation where we have this. I have a numerator as an expression, sine x plus cos x, and a denominator that is a fraction. Okay, you need to simplify this by doing tip and times. I'm gonna take the numerator as is, sine x cos x, multiply by the inverse of this fraction, which is gonna be a cos x over sine x plus cos x. So you're gonna flip it, right? You're gonna flip it. Then when we get here, this cancels out that, right? So with fractions you can only cancel what? Diagonally. You can cancel diagonally. So this cancels that. I'm now left with a cos x. Guess what? The left hand side is now equivalent to the right hand side. The right hand side is cos x. We calculated the left hand side and got cos x. Now for b. Okay, b. Okay, this one. Yeah. Not a difficult question, but the question is, what do I do here? There is no identity that I can use. Not 1, not even 2. However, looking at the right hand side, I can do this. I can take the right hand side and say sine x over 1 minus cos x. 1 minus cos x. Alright, 1 minus cos x. Remember, there is no identity, so you cannot use 1 or 2. Even this 1 cannot be changed into this identity. You should know why. You should know why, right? Because it's because of the fact that 1, the rule of thumb is you can only change this 1 if it's next to a cos squared, or the 1 it's next to a sine squared, like this, right? Like this. Whether there's a plus or a minus, right? Use that rule of thumb, okay? Use that rule of thumb. But you can see that the 1 is now next to a cos x, which is not squared. So leave it like that. What we can do, remember from complex numbers, there's something we did. We discussed. It's called the conjugate, right? So we're gonna do something similar to that. We are actually rationalizing the denominator. That is what we are doing here. Cos x. So I'm gonna multiply the numerators and the denominators. So sine, I don't actually need this sine to be multiplied into that. I'm just gonna leave it outside the bracket like this. You'll understand why. And then I have this multiplying this. Looking at the signs, and I'm rationalizing. I have a difference of 2 squares. So this one multiplied by that one, it's 1. Cos x times that cos x, it's minus cos squared x. Now, this one can actually be changed to that because it's next to a cos squared. So it's going to be a sine x, 1 plus cos x divided by 1, that one, let's change it to a sine squared x plus a cos squared x minus cos squared x. This cancels out that. I'm now left with a sine x, 1 plus cos x over, let's go, sine squared x. Now, we are getting closer to getting the solution for this one, right? This is the left and the right hand side. It's sine over 1 minus cos x. It's what we decided to work with. And then on the left hand side, I have a 1 plus cos x plus sine theta. I think it's obvious at this point that this sine should cancel one sine in the denominator. I'm now left with a 1 plus, let me not put the bracket, I'm now left with a 1 plus cos x over sine x. This is our answer. This is sine 1 plus cos x, 1 plus cos x, right? There was no identity, so we had to come up with something to assist us in solving this identity, right? That was rationalizing. Okay, next one. C. Okay, yeah, this is a toughy one. This is a tough one. Alright. Okay. I think here it would be safe to say the side that needs more attention is the left hand side, right? More can be done on the left hand side as compared to the right hand side. Something can be done on the right hand side. Actually, something can be done. But for now, let's just work with the left hand side, right? Let's just work with the left hand side. You know what's worrying me here? It's this tan x. Tan x is an identity. It needs to be simplified. So in such a case, we'll have to solve both sides. But first, let's work with the left hand side and see if we can't get to this point. If we can't, we'll have to, you know what, let's just do it. So I have a cos squared x minus cos x minus sine squared x over a 2. Wait a minute, the denominator actually has a common factor. This and this is a common factor. Let's take it out. So one of the rules that you should keep in mind when solving identities is actually asking yourself if there are any identity, if there are any common factors, right? So when I look at the denominator here, I can see that there's a common factor. Let's take it out. Sine x, I'm now left with a 2 cos x plus 1. This is gone, it's here. This is gone, it's here, right? So actually taking a common factor, it's like dividing, right, that term. So sine over sine, why sine is a common factor, it leaves us with a 1. So 2 sine x cos x divided by sine, we are left with a 2 cos x. Okay, now let's deal with the numerator. Okay, let's deal with the numerator. Someone might be thinking, hey, can't I take the cos x and the sine x and combine them and give me a 1? No, because the cos is positive yet the sine is negative, and both of them should be positive. So in this instance, here's what we can do. Actually use these identities. So these are derived identities from the squared identity, right? So if I take sine and transpose it to the right hand side, you can see that I'm left with a cos and the sine becomes a negative on the other side. Okay, and then now taking the cos over to the other side, I'm left with sine, and then 1. The cos, when it gets to the right hand side, it becomes a negative cos squared theta. We can use these identities. Why? Look, I think the best way to approach this is maybe if I do something about this numerator, I can see that I have a cos squared and a cos x. Then there's only one sine squared, right? There's only a 1 sine squared. So what I can do, I can change this sign to the identity of 1 minus cos squared. Why am I doing this? It's because of maybe I might end up with a quadratic I mean a trinomial that can be factored in a way, right? So that is why I'm changing the sign to a cos, just to make everything uniform over the numerator. Something might even cancel, something might be left behind, who knows? But let's check it out. So the cos squared remains, the cos x also remains, minus, now I'm going to open a bracket and substitute the identity for sine squared x, which is 1 minus cos squared x, close the bracket, and then you divide by sine x 2 cos x plus 1. We simplify, we have a cos squared x minus cos squared minus 1 plus cos squared x over a sine. I'm not gonna multiply by the sign because we took it out as a common factor, so let's just roll with it the way it is. So yes, now this cos and this cos is gonna give us a 2 cos squared x minus cos, not squared but x, it's just going to be a cos x minus 1 over sine x over 2 cos x plus 1. Okay, now the numerator should be factored as I've expected, as I've anticipated. We're going to have a trinomial. This needs to be factored. Level 2 factorization should ring a bell. You should remember this. Okay, so my hack, right? Or let me just say, here's a tip. This cos, this 2 cos x plus 1, when something needs to be factored on the numerator and you have something like this on the denominator, it means that one of the factors for that trinomial or whatever you are trying to factor out should have this as one of the factors, meaning that my first factor, remember whenever you are factorizing a trinomial, there should be 2 brackets. So the first bracket is this plus 1, and then the second bracket, it's obviously gonna be a cos x minus 1. If you know your factorization, well, you should be getting something like this: sine x 2 cos x plus 1. This gets cancelled by that. Now let's continue. Equal to, I'm now left with the cos x minus 1 over sine x. Now nothing else can be done except for doing this. Cos x over sine x minus 1 over sine x. I have this part. Where's this? Okay, I have this part, this and this, negative. However, I don't have the tan. So what we can do now is actually try to simplify the right hand side as well. So the right hand side can be simplified further into 1 over the tan. Let's change it. It's going to be a sine x over cos x minus 1 over sine x. I have a fraction. This fraction is being divided. This big fraction is being divided by a fraction. So it means that the simplification continues to 1 multiplied by a cos x over sine x minus 1 over sine x. We multiply by the 1, we get a cos x over sine x minus 1 over sine x. This similar to this. Now we just prove that the right hand side is equivalent to the left hand side. Okay, let's jump to the next one. Was that C? B. Okay, C. Alright, yeah, we are doing D. So With this one, it's obvious that we'll have to take the left hand side, isn't it? So again, left hand side, let's take u as our, yes, so left hand side is equal to, remember, tan x is a identity, so we're gonna change it to this. So it's gonna be a sine x, I mean alpha. We have a different variable here, so I'm gonna change it to a alpha cos alpha multiplied by sine, right? Multiplied by sine. Rewrite the sine as a fraction because I have a fraction multiplying sine only, right? I need to have fractions multiplying each other, right? So this guy is a fraction, this one is not a fraction, so you need to change it into a fraction so that when they multiply, you can multiply properly, and then nothing changes for the cos alpha equal to, so we multiply sine times sine, that's sine squared alpha over cos alpha plus cos alpha equal to, again I have a fraction adding to a term, right, to a term. So what do? I change this to a fraction. Do the butterfly method. 1 times sine squared, it's sine squared alpha plus cos times cos, that's cos squared theta over 1 times cos x, it's gonna be cos alpha. Now this is actually an identity, so it should be changed into that one. So it's gonna be what? 1 over cos alpha, which is the same as the right hand side. Okay, next one, E. Let's go. So left hand side, you need to be simplified. Left hand side, I have a 3 cos x over a 1 plus sine x plus 3. Okay, this tan is gonna be changed into a sine x over cos x, right? You can see that there's only 1 3. There's only 1 3 in front of the tan x, so don't make the mistake. This is a mistake, né? This is a mistake. I'm gonna write it in red. Mistake would be doing this. Left hand side equal to 3 cos x over 1 plus sine x plus 3 sine x over 3 cos x. This is completely wrong. Okay, this is completely wrong. There's only 1 3 in front of the tan x, so keep it like that. Okay, now actually the 3 should be placed next to the sign, right? Should be placed next to the sign. Now I have fraction 1 adding to fraction number 2. So what do? We tip and times, right? No, not tip and times, but butterfly method. This multiplies that. It gives us a 3 cos squared x. This multiplies the 3 sine x. It gives us a what? A plus 3 sine x multiplying this 1 plus sine x. I want to take it step by step. And then this multiplies that cos x 1 plus sine x. Let's continue. We now have a 3 cos squared x, a plus and a plus 3. Now let's distribute this inside the bracket. I'm now left with I now have a 3 sine x plus 3 sine squared x. 3 sine squared x. Okay, let's continue. Don't multiply this bracket yet. So remember, there's somewhere along the way it should be cancelling out something on on the numerator. This denominator part should be cancelling something on the numerator. You know what we can do? I can see a common factor of 3. Why not take it out? Why not take it out before your mind starts running wild, thinking, wondering what's next? So the easiest thing to do here is actually taking out a common factor of 3. Sine squared x over cos x. Do you see it? Uyayibona na? Can you see it? I see it. This, when combined with that, it gives us a 1. That's an identity. Okay? I'm now left with a 3, 1 plus sine x. This one is coming from this and that. Divide by cos x, 1 plus a sine x. So u get divided by u. I'm now left with a 3 over cos x, which is similar to the right hand side, isn't it? Okay. E f. Let's go for f. Okay, that's f. That's f. I think it's obvious what you should be doing here. Taking the left hand side. We should be taking the left hand side and simplifying that. So it's gonna be a sine squared x alpha open bracket. So that tan is an identity. Let's change it to a sine alpha over cos alpha plus 1 over that tan as well. On the denominator it's also a identity. Let's change it. Then we simplify further. Okay. Sine squared alpha, and then this remains over cos alpha plus a fraction being divided by, okay, it's a fraction with the denominator as a fraction. So what do? We're gonna say 1. We take the numerator as is, dividing it by 1 if you want to. Okay, but you have to, man. Then you multiply by the inverse of the denominator. So you flip the denominator. It's gonna be a cos alpha over sine alpha. Close the bracket. Equal to. So it's gonna be a sine squared alpha sine alpha over cos alpha plus 1 times cos, it's cos alpha over sine alpha. Then you tip it, not tip in times, but butterfly method. You multiply u. We are still inside the bracket. It gives us a sine squared alpha plus u multiply u. You give us a cos squared alpha over sine multiplied by cos. We end up with a sine alpha multiplied by a cos alpha. Close the bracket. I see an identity, the identity of 1. So we're going to change that to a 1. It's going to be a 1 over sine alpha cos alpha. Okay, cos alpha. Perhaps we can take this. You see, whatever is inside the bracket, it's a fraction. So I'm going to divide this by 1 because I'm gonna multiply, the brackets are saying multiply this fraction that is inside the bracket with the sine squared. So I'm changing this to a fraction. The numerators multiply each other. Sine squared alpha over 1 times this, it's sine alpha multiplied by cos alpha is equal to u get cancelled by u. I'm now left with 1 sine on the numerator and a cos on the denominator. I think it's obvious what the answer is going to be, a tan alpha, which is the same as the right hand side. Okay, EFG, let's do G. Okay, what a mess, what a big mess. Left hand side is equal to Okay, not so much of a big mess, but you know, there are some things on there that we did not discuss in class, but it's fine. It's this sine negative x, which, by the way, it's a negative angle. We're gonna discuss this once we get to that reduction, to that formula. So sine 90 degrees plus, this is a cofunction. This cofunction is found where? In the second quad, right? It's a cofunction in the second quad. This is in the third quad. It's a reduction formula. This is a cofunction, and then this, it's a reduction formula, third quad, and then this, it's a reduction formula in the fourth quad. So here we actually need what? Cast rule. We need the cast diagram. Okay, let's solve this. It's gonna be in the second quadrant. In the second quadrant, sine is what? Is positive. So it's gonna be a positive cos x. Let's put this in brackets. Let's just put this in brackets. I'm gonna say it's a plus, a positive cos x, multiplied by. All right. So this is a special case of when we get to simplifying trigonometric expressions. I see a negative angle. The moment you see a negative angle, you're gonna add a 360 degrees. You always add a 360 degrees whenever you have a negative angle like that one. So the sine now changes to a 360 minus x. I added 360, right? Then we continue. This is going to be a positive tan x over, and then a positive cos x again, because this is found in the fourth quadrant, and in the fourth quad, who's positive? Cos. So when simplifying this reduction formula, we're going to get a positive value. So sine 180 plus 180 plus what? Plus x. So this is found where? In the third quadrant, and in the third quadrant only tan is positive, so it's gonna be a minus sine x when simplified. Okay, I can see that this gets cancelled by that. Let's continue simplifying this. I'm gonna get a minus sine x for that, multiplied by a tan x, a positive one, divided by minus sine x. This cancels this. I'm now left with a tan x. The calculations were math. Yes, boy. G. The left hand side is equal to the right hand side. Yes. GH. I believe you are the last one. Marunga be now. Don't be a pain in the behind. Alright, so here, left hand side. So left hand side, we have the sine theta. Wait a minute. I see a common factor here. Why not take it out? Let's start with that. So sine, get out. We're now left with the 1 minus 2 cos x. 2 cos x over. Okay. Okay. This is actually a trinomial, right? It's ax squared bx plus c. This needs to be factored. So look at the x squared as that cos squared, that x as that cos theta, right? So this is telling us that we have a quadratic or a trinomial on our hands. So we need to factorize this, right? We need to factorize this. So using your knowledge from level 2, you should be knowing this stuff, guys. So let's factorize this. Here I'm gonna have a 2 cos theta, and let me see, plus, okay, plus here, so it's gonna be a minus 1 and a 1, not a 1 but cos x. It's a theta here, so theta plus 1, right? I know that. I think on one of the questions I did highlight that if you're gonna factorize something or anything, right, and it is a trinomial involved, one of the brackets that should be factored, or one of the brackets that is a factor from that trinomial, should be similar to what is above or below that trinomial. Okay, so I know that I should be having a 2 cos theta somewhere, which is this, right? They look the same, right? They almost look the same, but the only difference here is what is the signs. So for this bracket, I'm gonna do, okay, in fact, why not do the sign change here? I'm gonna apply what we call a sign change rule. We're gonna apply the sign change rule. So why are we doing that, and how do we do it? Is we actually take a minus out of this bracket. So minus out, I'm now left with a sine theta, open bracket, 2 cos theta minus 1. So the sign change rule, what it does, it changes the sign for this term into a positive. Now it's positive, you can see that. And then it changes the sign of this one into a negative. Now it's negative, right over there. Divide by, okay, it's now the same as the one below. That was the whole point of doing the sign change. So you now have this cancelling out that, equal to a minus sine theta over a cos theta plus 1. You now have the right hand side being equal to the left hand side. Okay, this concludes our discussion, our lesson for the activity on trigonometry, on general trigonometry. So here we were discussing identities. Check the description box for more sums that were part of the exercise. So check out part 2 in the description box. I hope we like it. I hope you enjoyed. Catch you on the next recording. Peace.